Now let us take the example of a throttling device. Okay, so what is a throttling device first? See, throttling device is mainly used in refrigerators and many other devices to sharply reduce the pressure. So fluid enters from here. You can see that when it flows through this, okay, flows through here from the throttling device, at the exit, its pressure will be drastically reduced. So this is mainly used in refrigerators. You can see that for a throttling device, uh, it is completely insulated. Okay, there is no heat flow outside, and also you can see that here no work is produced. There is no work produced. So you can use the steady flow energy equation we have derived. This is the general steady flow energy equation, that is q dot plus m dot into h1 plus v1 square by 2g plus gz1 plus the work supplied plus m dot into h2 plus v2 square by 2g plus gz2. So when you make the assumptions that q dot, it is not an assumption, it is for a throttling device, q dot and w dot is 0, and and one assumption here is usually in a throttling device, the inlet velocity is equal to exit velocity. There is not much change in the velocity of the fluid. So V1 is equal to V2. So if you, and also these are at the same level, that is Z1 is equal to Z2. So that means, so this will get reduced to m dot into h1 plus v1 square by 2g plus gz1 is equal to m dot h2 plus v2 square by 2g plus gz2. So if you, so since v1 is equal to v2, you can cancel these two, and also z1 is equal to z2, you can cancel these two. So that means h1 is equal to h2. So for any throttling device, the enthalpy of the fluid entering is equal to enthalpy of the fluid going out. So sometimes you may be asked to show that in a throttling device, enthalpy in is equal to enthalpy out.